So I hope you can already hear me. Thanks for attending today. Today I'm going to present you a webinar about our lifecycle assessment of the GEN24 Plus. So in this webinar we will talk about product related topic, but not on a technical level, more on a sustainable level. So we will answer some questions today. What is a lifecycle assessment? Why can it be important for you as a customer? And of course, we want to present you the outstanding results of our LCA of the GEN24 Plus hybrid inverter. But first of all, short introduction of the speakers today. So on one hand side, it's me, myself, Leonhard Peberg. I'm working in the team product marketing here at Fronius International. And I have my friend here, my colleague in the chat support, that's Mathieu Delpierre from the system technology department, who is really the expert for lifecycle assessments. So please, if you have any questions during the webinar, just put them into the in the menu panel on the right-hand side, and my colleague will answer it immediately. And for the most important questions, we will have a Q&A session in the end, and we'll answer the questions, of course, also live. Yeah, quick look on the agenda. The first topic will be sustainability by design. This is our department here at Fronius conducting these lifecycle assessments. Then I will, of course, explain you for the people are new in this topic, what is an LCA and why is an LCA important for you as a Fronius customer, as an end customer, as an installer. And of course, the biggest topic will then be topic 4, which is the results of the LCA of the GEN24 PV inverter. Yeah, first topic, sustainability by design. On this picture, you can see Günther Fronius, who is the founder of Fronius in 1945. And you can see our first, let's call it product on this picture, and that's a charger for car batteries, for broken car batteries. So you can see the first way of thinking was already in direction reuse things, not throw away things. Really, sustainability wasn't even a topic here, or I think it wasn't even a term in these times, but it evolved, of course, and also it evolved with Fronius. So sustainability is a huge topic for us nowadays, and we had like the problem to we wanted to be very sustainable, but we hadn't like a measure to measure sustainability, and we wanted to know the exact carbon footprint, the eco balance of our product. And so some years ago, we founded the department Sustainability by Design in our R&D in Thalheim by Wels in Austria. And these colleagues of mine, they conduct life cycle assessment. So they measure the carbon footprint of our product. And in this case, evidence-based sustainability along the entire product life cycle is very important. So we need to be 100% transparent here. And that's only possible with facts, facts, facts. And that's what my colleagues in Thalheim are doing. They produce facts for our products in terms of sustainability. Yeah, what is now a life cycle assessment? An LCA is basically a sustainability assessment of the environmental dimension. On the right-hand side, you can see the 3 pillars of sustainability. Maybe you saw this diagram already. So sustainability is always or moving in the field of profit, people, and planet. So people, one example for social sustainability would, for example, be fair wages. Of course, profit is also very important. For example, fair operating practices, also through competitors, and of course, the planet. Planet is extremely important, and planet is those what we can measure. So with the life cycle assessment, we basically measure the impact of a product on the environment, on the planet. Yeah, why can a life cycle assessment now be important also for you? The first most important fact, in my opinion, is that we need evidence-based sustainability. I think nowadays every company is somewhere sustainable, I don't know, using green claims and so on, but sustainability is a very sensitive topic, and you need facts, you need high transparency in order to really use sustainability as a key value for your company. And so you need to refute the accusation of greenwashing by having evidence-based sustainability. And therefore it needs like something like life cycle assessments to prove something, to prove sustainability of products. Of course, also the customer requirements are changing. So we get a lot of emails from our customer sales partner. They want systems with a high carbon with the best carbon footprint. They want to know how much CO2 SNAP inverter GEN24 is causing in their country. And of course, they want also to have these measures to get, for example, fundings from the EU. So it's also a financial topic, of course. But so the customer requirements are changing. 10 years ago, there was nothing like that. Now it's getting more and more. Also, CO2 pricing is rising. Of course, you can see here the map of the tax foundation for whole Europe with the CO2 pricing. So the prices per ton of CO2 is rising, and these prices are basically passed on to the end customer, of course. So environmental friendly products will become cheaper for our customers in the futures, becoming now, but in the futures, of course, more. And on the map, you can, for example, see in Sweden, for example, it's already very high price with 117 euro per ton of CO2 equivalent. And for that, of course, LCA data is becoming crucial to also measure these values and give them a price, of course. Yeah, now from, let's call it the situation now, the status quo, the problem to the solution, and that's the life cycle assessment. I just want to briefly start with the general life cycle of the product. It's always the phases of sourcing to the end of life. So we scrutinize all these phases from sourcing, where's the raw material of the product coming from, then the transportation to the production sites. In our case, for example, Zadlet and Krumlov in the Czech Republic, where of course the products then are produced. The footprint is rising, CO2 is embedded into the inverter. Then of course transportation to the customer side, where you have the usage phase. This is also very important. Also during a usage phase, the CO2 footprint of a product can, for example, getting more and more. If you think about a cell phone, for example, you of course have to charge the cell phone, and by charging a cell phone, the carbon footprint rises, of course, during the lifetime. With our inverter, it's a bit different because it's producing green energy in combination with the PV system, and therefore the inverter is basically working off the carbon footprint in the usage phase, originating from the production. And of course, every inverter, every electronic component will have an end of life someday, and also this end of life scenario, the waste management is examined in this life cycle assessment in very, very detail. Just some impressions of this life cycle phases. Basically, the sourcing phase, where is the iron of the inverter coming from, the bauxite for the aluminium, the copper, and so on. Then, as I said, the production side, here you can see a colleague in production producing a GEN24 inverter. We use, for example, 100% green electricity in our production sites. The transport is very important, so train, ship, and truck transport. We completely avoid air freight within Europe, for example. That's also a key benefit in terms of sustainability. As I said, the usage phase is very, very huge. I will come to that in more detail later. And of course, the end of life phase is also very important for the product, because there is a huge difference if you, for example, just landfill the inverter, or if you disassemble it and then recycle it, for example. Yeah, now the biggest part of my presentation, the most important topic for today, our life cycle assessment of the GEN24 Plus hybrid inverter with all the steps and results. Before that, I quickly wanted to tell you something about transparency updates of life cycle assessment. As you know, we use these results of a life cycle assessment to continuously optimize our product development. And of course, we need to keep this data up to date. This is very relevant for us. And for this reason, we from time to time update our life cycle assessments when this is needed. And since a very high degree of transparency is also required here, we want to really also communicate these updates to our customer. A life cycle assessment is a very livable, vivid thing, I would say, and it's not a fixed value which is there for 10 years. It's always changing something. Components are changing, PV modules are changing, the database where we get our secondary data from, that's echo and vent, is changing. So we're continuously updating our life cycle assessments, and we had the first update for the LCA of the GEN24 last month in February 2023, and of course there will be more continuous updates of the LCA, just that you know that we're also communicating these updates. Yeah, before I start with the results, I want to show you the project team of the lifecycle assessment in our R&D. So a lot of guys were working with the lifecycle assessment. Also, external service provider helped us with serving this model for the LCA. Of course, a lot of internal stakeholder, and also the Fraunhofer Institute of Germany reviewed our lifecycle assessment, that everything was done correctly according to the ISO guidelines for lifecycle assessments. Yeah, the first important thing is the scenarios. So you can imagine a LCA, as I said, it's not a fixed value. It's depending on a lot of different variables, and so we set different scenarios. For example, the first big point is the location of usage. We modeled in our LCA different locations. So is the inverter located in Austria, Germany, Poland, Hungary, Brazil, Australia, and USA, New York, and Los Angeles? So there's also a difference in insulation in the national grid electricity mix. So there are a huge variables in this country setup. Then we have the PV system. So do we use conventional PV models or a more sustainable alternative, which is arising in the last few years in the market quite commonly? Then the Fronius inverter, of course, for example, is it a Primo GEN24 3.0 or a Simo GEN24 10.0? Of course, there's also a huge difference because we have more AC output here. Then the selected waste recycling scenario. So, for example, as I said, do we use a landfilling after the lifetime of the inverter, or do we use a recycling with the disassembly of the main parts of the inverter? And some additional parameters like, for example, repair processes and origin of the electricity for the night consumption of the inverter, but more on that later. So what you can see, we have a huge variability of scenarios here, and I think we got more than 16,000 results, or even more. I don't know exactly by heart the number, but it was a huge effort in our R&D department to calculate this life cycle assessment. Yeah, for a good LCA, you need good data. Data quality is basically key for a good life cycle assessment. We had a lot of primary data in our R&D, where we got a lot of details and information of our suppliers regarding the carbon footprint of single components, of capacitors, of semiconductor elements, and so on. And of course, we used some secondary data for the data for PV system components like module, PV cells, and so on. So yeah, data collection is basically very important. Some illustrations of our data collection to give you an impression how this worked in our R&D. So in this picture, my colleague, for example, dismantled the fan of the GEN24, the fan by a hammer. So it was also a hands-on work of my colleagues here. Here you can see the print of the GEN24. We also searched for some gold components also. This was the data collection of a coil, for example. Of course, we measured everything in detail. You can see here the cut foil capacitor. So yeah, you can see it was a really hands-on topic, not only sitting in the office and calculating something in an Excel file. So it was more than that, of course. And of course, all the safety requirements have been fulfilled when dismantling an inverter. You can see my colleague here. This is just the illustrative presentation, of course. Also, in the production site in Satlet, the power consumption was measured of the GEN24. And last but not least, regarding the end-of-life scenario, we had some talks with the Austrian recycling manufacturer Müller-Guttenbrunn to also discuss these end-of-life scenarios and how this impacts the life cycle assessment of a GEN24 Plus PV inverter. Yeah, now I want to show you one scenario at a glance, because I said in the beginning there are a huge variety of scenarios. I could present you Brazil and Poland with different inverter types, with different I don't know, waste management scenarios, but this would take me a couple of days maybe to present all those scenarios. So we just took one very praxis orientated scenario, which is a GEN24 Plus 5 kilowatt inverter with 20 years of operation in Germany, conventional PV modules, and a thermal waste treatment with subsequent metal recycling. Basically, is meant with that you recycle the metal parts and then the rest you treat thermally and use the energy of that. Yeah, before that, I quickly want to show you the carbon footprint of a whole PV system. As you can imagine, the inverter is just a single component in a PV system. The inverter needs the energy of the PV modules. The PV module needs the inverter to invert the energy, so it's a holistic system. So we have to look at all the components. That's very, very important. And as the inverter, you can see in this diagram, accounts for 19.1% of the climate impact of the whole PV system, and therefore also it receives 19.1% of the climate benefit. So what we did in the LCA was, on the one hand, calculating a carbon footprint, so the climate impact of the product, but of course the PV system also generates a climate benefit in the end after 20 years in our calculation. So from this climate benefit, 19.1% goes in the direction of the inverter, and the other percentage goes in the direction of module manufacturing, PV cells, and what you can see here, for example, in this diagram. This is a very important slide. Yeah, and that's basically the climate impact of the whole life cycle, over the whole life cycle of the inverter in our specific scenario with the GEN24 Plus 5 kilowatt in Germany and so on. This inverter would produce a carbon footprint over 20 years of 804 kilogram CO2 equivalent. This is just the climate impact, as I said, and not the climate benefit the inverter is producing. That's just the carbon footprint. And this carbon footprint is allocated, you can see in the right, on the right-hand side of the slide, you can see different steps. So a very huge part, I will go through it in detail on the next few slides, but a very huge part is caused by the night consumption of the inverter. More on that later. Also, the electrical losses are quite high with 13.6%. The transport to customer to Fronius and also the production at Fronius has a very, very low impact on the carbon footprint. The components also have a huge impact on carbon footprint. And the waste recycling scenario, it's basically a minus value because it's, let's call it a sustainability voucher. We get back some footprint here because we have some primary resources which not need to be produced because we recycle something. But more on that also on the next few slides. First topic, the components of the GEN24 SIMO 5.0. So you can see here the aluminium part, the technical plastics are causing a huge share of this graph in terms of weight. So they are quite heavy components. Also the coils, but the other things like, for example, capacitors and semiconductor elements like the ICs, they are not even in the diagram here, so they're causing a very low impact by weight. What's very important on the next few slides, that's the climate impact of the components, and this looks completely different. So in this diagram, you can see, for example, that the aluminium has also a big share, but in terms of weight, but also in terms of climate impact. But some very small components, like for example, the IGBT semiconductor modules or the IC semiconductor modules, capacitors, they are a very low impact in terms of weight, but a huge impact in terms of climate. And that's a good, I would say, a key value or a key message of this LCA, that very small components can have a huge impact on the climate. So basically, just to get back, sorry, 30.5% of the whole of the components of the climate impact is caused by the components. Something about aluminium, because I showed you on the last slide, the impact of the recycling share in the alu heatsink. We're using a heatsink made of aluminium, but we're not using 100% new product. We're using 100% recycled product from open loop recycling, and this causes nearly the half carbon footprint value in comparison to a new product. So this is a big lever of the LCA, that we use recycled aluminium in the heatsink of the GEN24 Plus PV inverter. Yeah, the next impact category is the transportation to Fronius, just 0.8%. We scrutinized all the countries of origin of the components, did a calculation of the average mileage of each country to origin to Fronius, and so on. So we did it in a very granular level, very detailed, but it's just causing 0.8% of the climate impact, because on the one hand side, the logistics is already very good. Yeah, and we'll try to avoid the air freight within Europe, so this is very low. Also, the production at Fronius is very low, with 1.1% of the climate impact. So the power consumption was measured here. I showed you a picture of that. The gas consumption, diesel consumption, nitrogen, compressed air, solder paste. So we really measured everything here, but also this is a very low number, for example, because of that reason, that we really use 100% green electricity on our production sites, and we have a huge PV site and the ice storage on site. So yeah, we generate a lot of the energy by our own. Also, the transportation to customer is quite low. I mean, in this scenario, it's from Austria to Germany, so the mileage is not very huge. But as I said, by truck, this is not a very huge thing. Also, the Australian scenario, for example, if we would ship an inverter to Australia, this would be not that much bigger. It's maybe a bit over 1%, but so that the whole logistics is not causing a huge climate impact anymore. Yeah, another very important category is the electrical losses during the usage phase of the inverter. So as you can imagine, or as I told you already in the beginning, we have to look on the system as a holistic system with the PV modules and the inverter, because the one needs the other basically. And the PV modules also have a CO2 backpack originating from the complex production process, so a very huge carbon backpack. And this is partly lost in the inverter as waste heat, because of course an inverter has a certain efficiency, which is extremely high with 96.8%. But yeah, this 2 point something percent or 3 point something percent is basically lost throughout the inverter. And this is causing a huge share of the carbon footprint of the whole inverter, because it basically burns the energy of the PV module, which already has a huge CO2 backpack. And the biggest share of the cake is basically the night consumption. So the inverter, of course, consumes energy in the night for battery management, data management, and this energy must be drawn from the power grid, and thus has, of course, an impact on the CO2 footprint. That's strongly depending on the country-specific power mix. So we use the country-specific power mix for that calculation, but on that slide, you can see how this footprint would be reduced if you would use a green electricity tariff. So in this case, in Germany, from 56% to 9.6%, the night consumption would be reduced by just using a green electricity tariff. So also, if you have a PV system, please try to use a eco-friendly green electricity tariff in addition, that you can really also decrease the carbon footprint. If you would have a PV battery, of course, then this night consumption can, of course, be drawn also from the battery and would have another impact on the carbon footprint. Yeah, last but not least, the waste recycling, it's minus 2.1%. As I told you, there are different scenarios for waste recycling. The one we used, I can show you on the next slide, is that one, waste incineration with metal recycling. And for those three management methods, we have a negative carbon footprint, meaning these negative values come from the credits from primary production or replaced fossil energy sources. And just by landfilling or waste incineration without the metal recycling, we would increase the carbon footprint. but this is quite a practical scenario to basically recycle the metals and burn the other stuff of the inverter, and then use this, of course, thermally. This is quite the practice, I would say. Yeah, also because I said dismantling has a huge benefit. That's basically generating the highest benefit if you dismantle the inverter before you throw it away. And then, of course, recycle the key components. The dismantling time is around about 5 minutes, so it's not that much effort for you. That's, for example, the alu heatsink, the wall mounting, the EMC case, and the 3 plastic housing parts, which you can basically dismantle and then recycle as a single component. This would generate the highest benefit in terms of climate. Yeah, also repair has a huge benefit or a huge impact on the climate, a positive impact on the climate. So we modeled also repair scenarios, repair procedures, like for example, the replacement of the fan on site, or the replacement of the data communication on site, the replacement of the resistors on the power unit in the repair center at Fronius, and also the replacement of the entire power unit print on the repair in the repair center. And all these repair procedures generates a huge benefit on the climate impact of the product. Yeah, now I talked a lot about the climate impact of the product, but of course, as I said in the beginning, the inverter is also producing a huge climate benefit. What you can see here in this diagram is these impact categories we measured. So I talked just about the climate benefit in this LCA, but of course we also measured some other categories like impact on fossil resources, metallic resources, human toxicity, and so on. So this was very a detailed life cycle assessment. Of course, the benefit is the good one, the impact is the bad one. So especially on the climate impact, which is the most important category in my opinion, the climate benefit the inverter or the whole PV system is generating is far higher than the impact the system generates. Here, this whole thing is expressed in a CO2 payback time. So this is basically the time until the whole PV system is carbon neutral. So the PV system, including a GEN24 Plus 5.0 in Germany, the payback time is in the range of 2 years. So after 2 years, the whole system basically worked off the carbon backpack and produces green energy day by day. And over all scenarios, the best case scenario is a GEN10 in Australia, which has a payback time of 0.7 years, and the worst case is a Primo 3.0 in USA, New York, with a CO2 payback time of 3.3 years, which also is very, very good and fast payback time. Yeah, we can also have a look at the energy payback time. Of course, this is also a very important value. So yeah, the time the inverter or the whole system needs to allocate or to work off the energy originating from the production and so on. Also in the German example, this would be 1.3 years, and overall scenarios, this is ranging from 0.6 years with a GEN10 in Hungary to 1.8 years worst case with a Primo 3 in Austria. Yeah, just to sum up the most important results of the life cycle assessment, the environmental benefits of the whole PV system exceeds the impact by a factor of ranging 9.1 to 44.9 times. So in the best case scenario, the climate benefit of this whole PV system with the GEN24 exceeds the impacts by a factor of 44.9 times, which is of course a huge number. Sorry for that. Also, the payback time of the climate impact is in the range of 0.7 to 3.3 years. I already mentioned that. So also a very fast CO2 payback time, and in concrete values, in concrete numbers, up to 516 tons of CO2 equivalent are saved with one PV system with a GEN24 Plus, and this would, for example, be 235 outbound and return flights from Vienna to New York, what you can compensate with a PV system with a GEN24 Plus inverter. So this is, in my opinion, a very, very huge value. So how can now I, as an installer and customer, use this life cycle assessment? This is the advantages and fields of application for LCA, just a repetition. Some of them I already mentioned. First, of course, it's very good to have a green image to use sustainability as a figurehead for the installation company. But of course, for that, you need really facts, you need transparent values of a life cycle assessment. And we give you like ammunition for your selling process with the life cycle assessment. CO2 will get a price. As I said, from an economic point of view, the inverters with a low CO2 footprint will be preferred in future. It gives you economic safety when it comes to tenders. So also this environmental impacts of a product, they will be required in future tenders more often. For example, in France, this is already part of some big tenders above 100 kilowatt peak for PV modules. And the economic efficiency versus the environmental awareness, I think the economic efficiency of a PV system, that PV pays off, this is basically done. Everybody knows that PV pays off, but now it's going more in the direction of environmental awareness for future requirements for your children and so on. So be part of the energy transition with Fronius and with the life cycle assessment. We also have some additional documents like a white paper with the LCA GEN24 Plus, where we explain everything in very, very detail. And of course, also the review reports of Fraunhofer Institute for the LCA. Just scan these QR codes or do a screenshot or so. We of course give you the presentation later on, so you can have all the links later on when you have time to go through the slides. Yeah, that was basically all now from my side regarding the presentation. And now my colleague Mathieu can come up to me and we will have a look if there are some questions. Are there, Mathieu?
I haven't seen so far. Maybe I missed it, but so far I haven't. So if there is any question, feel free to ask, and it will be my pleasure to answer them.
Perfect. Sounds like that we did a good job. When there are...
It was really clear, really comprehensive, consistent. So no, really stimulating webinar with many fact-based sustainability elements.
Very good. Then we will stay online also for a few minutes. So if you have any questions, please just shoot them into the chat. We will now mute our microphone and cut the cam, and we wish you a good, sustainable day. Thanks, guys. See you.
Have a nice day.